Hello everybody. So today I will show you the talk on Spring Native Batch. So let's start. Great. So it was Flash. And why Flash? Because Flash is quick, is fast, and that I want with my Spring Batch. And so, I can have a Spring Batch that I as fast as Flash. It is thanks to Native Image and Graal VM. So let's see today. Speed up your Spring Batch with Native Image and Graal VM. And I do this talk for Spring Meetup Paris with the title, the subtitle, Make your Spring Batch fly with Graal VM native image and save on FinOps cost. Because if it is quicker, it is less, it's cheaper. So I will present you these topics today in this talk: the definition of native image, the definition of Graal VM, the requirements for this practice that we will do today. Then how we will create the Spring app, what we need for the Spring boot or Spring Batch app. Then we will compile it in native image. We will discuss the benchmark with our result native image. And in the end, we will speak about the limit when you need to know if you want to go further with native image. What is a bit dangerous and what is very really cool for this, and what are the different points to consider to go forward with native image. So the context, I work in a project where we have a multiple batch, more than 20, and we have some loading of libraries that contain more than 8,000 classes. So it is a very tedious to spare some memory, some CPU, because each time the Spring Batch start, there is a loading of the classes, and these classes take a lot of memory and have a peak of CPU. So that's why I was interested by this native image, because this native image can, we'll see it later, load all this class in the image. So, and since 2022, we have Spring Native, which allow us to have a native image. So what is native image? An autonomous exe with optimized performance and great for short tasks. Let's see this in detail. So an autonomous exe, traditionally with a GVM, you have an executable jar with the application code, Spring Framework, Spring Boot bytecode, and hotspot VM, which is the GVM, the hotspot VM being the GVM for Oracle. And then for an image, a native executable, you have the application code, the Spring Framework, the Spring Boot, native machine code, initial heap, dwarf info for the debugging, and a substrate VM, which does the job if we want of the GVM, but inside the native image. So it is a standalone and not something with a GVM apart. So remember this. Traditionally, we have in two pieces, and with native image, we have only one part. And what do we gain with this native image? We consume less CPU, we consume less memory, we have images that are smaller, we have a shorter startup, and we have, since the beginning, the max performance for the application, and we have more consistent response time. So in the end, all of this help us to reduce the FinOps cost, which is one detail very important for a lot of customers: the budget for the project and the infrastructure. So now let's define Graal VM. Graal VM is a universal virtual machine. We'll speak about the ahead of time compilation, which is inherent to Graal VM, and the advantages for Spring Boot. So a universal virtual machine. because it is polyglot, it can handle several languages besides Java, like JavaScript, Python, and JVM language. And those we are not JVM language are handled thanks to the Truffle language implementation framework. And so we have a great interoperability, not only for JVM language, but also for those languages that are not JVM language. In the topic of compilation for GraalVM, you have this path. You have the app source, then it gets to the compiler plugin, JavaC. It creates bytecode, but it is not the only path. There is a second parallel path with ahead of time plugin that add additional bytecode with native config, and all those are aggregated in the GraalVM plugin to produce the native exam. While in the JVM classic way of compiling, you have the app source, which is compiled in bytecode thanks to Java C compiler, and then it is processed by the just-in-time Java plugin to produce the machine code for the CPU. So we have seen native image, GraalVM. It's time to get our hands dirty and to practice with this um, uh, topic of seeing which is better. And we need for this some requirements: the GraalVM, the Visual Studio and Visual Studio Code, PostgreSQL. So let's see how to get all of this. So to get GraalVM, you go on the site of the Oracle GraalVM, you download the version. I use for this practice task the one for Windows machine. And there is a tutorial to explain you how to set up all of this. For example, the Java Home, etc. For GraalVM. So it's pretty well defined. So I think you will not have some problems with this part. Then you need the C++ suite to be able to compile with the C++ API. So you download Visual Studio Community 2022. It's free. It is not the one that you with a fee. So you take the free one and you choose when you install it the desktop development with C++ option. And then you tick this box that I put here, which is necessary to compile in native image. And the last part required to be able to do this little coding kata, it is Postgre database. So we run a Docker command to load database in a container. So now Spring Boot app creation. Let's see what we need inside the Spring Boot in terms of code. So to create the application, the Spring Batch application, I went to the Spring Initializer. You have the classical option, and the more important is to choose these dependencies. The first one is GraalVM native support, which is required to be able to have a native application, CRUD native application, Spring native application. Then you have these two dependencies to be able to interact with the database, and then you have the Spring Batch to be able to have a batch. Talk is cheap, show me the code. Do you know who said that? It is Linus Torvalds, because you know the talk is the more explicit to explain what we do in the business in a coding application. So let's see this. It's a billing application. We have a business object with the year, month, account number, phone number, amount, calls, message. So this is our business object. Then we have the batch, and in this batch, you have the job and the step. Here, it is a way to load or to interact with the entity manager, which is necessary to interact with the database. Then you have the job. The job load the step load different subtasks, a reader, processor, and a writer. Let's see them now. So for the reader, we have a CSV reader. Here we put the colon and it transforms it in an object, which is the billing.class. And then we get to the processor, which only print it out. and we could have in this part added some business rules like apply a 10% increase, etc. But it was only to show uh, at least the startup time. So the processing and on the business rules were not the part the most relevant for this presentation. And in the end, we have the writer which write to the database with thanks to the entity manager factory, and we have a launcher with the command line runner which does the launching of the batch at the beginning of the Spring Boot application. So now let's compile it in a native image, clean compile. So first of all, we clean the project, okay, and then clean package. Then we launch this command. So profile native. This will compile in native. This is used to skip test. So this command will help us to compile our application in native. So let's check this. I will not build again the application. If you want, I just launched it just before. So you have this kind of logs. So it is pretty long. It took, 6 minutes and 25 seconds. So you see, it's pretty long to build in native. Okay. So we have built in native. Great. So now we will compare the classical running of a Java application. I do this. This is the application running on a JVM. So here it is the insertion of the data of the CSV. Now I will check the start time. You see here it starts in 5 and 585 seconds. Let me copy it. Okay. So I will and we have it in database. You see here you have the content, view table, data. Okay. So we have the content. So now I will launch the Spring Native one like this. So you see it's start instantaneously, and I will check the start time. Started in 0,147 seconds. So I go to my browser. I open a tab, and here I do this divide by the native, and it is 40 times faster than a JVM application. So here is the benchmark we can try out together to see how it is quicker with native image. Okay, let's get back to the presentation. So the benchmark without native image, with a native image, the result, and the winner is native image. So this was a previous score I did in a previous video. I had a startup time of 4 seconds without native and 0.2 seconds with native. So you see the difference. And there is a lower resource consumption with native image. Then you see that you have a single executable, while in the traditional way you have a JVM plus a jar. Then you see that it is instantaneous for the startup time. It is a bit slow for the JVM. And you see in the end that it is the best way for short or on-demand jobs. You could have said that, okay, you did it like this on your PC, but it's not a real benchmark. You have to do several times on several conditions in different contexts to check it. So I have not do all this benchmark, but GraalVM did it by itself in a paper available on Oracle at this address, and you see that in this different benchmark, you can have a difference of 4 times more performant with GraalVM than a static Java JDK8 configuration. So you see, you can have 4 times quicker more performant um, result with GraalVM. And here, it is also something that I didn't explain in detail, but in red, you have the GraalVM Enterprise Native Image, and in yellow, in dash, you have for Java Development Kit, JDK. And you see that because with just-in-time compiling, you optimize more and more your application with the queries coming in. So the most you have queries, the most it is optimized. But in the end, you see that you have already the max performance compared to JDK. So it is better to have a native image than to have a JVM configuration for this same kind of results. Okay. And the conclusion was a native image is ideal for fast starting and relatively short-lived microservice. JIT is a better option for traditional long-running Java workload. Okay, because GraalVM JIT has a 16% higher performance, but you see, compared to JVM and GraalVM, classic GraalVM, you have in the end the same result. And at the beginning, better, higher, 1,500% higher result for the GraalVM part. So the limits: a complex build, a slow build, less mature than the GVM. The GVM is there from a while ago, so there is a lot of stuff that have been debugged and documented. You have also a problem of parity between dev and prod. For example, I do my application on Windows, and if I want to deploy it on a Linux Alpine, it could be a problematic. So and on the CI, it will be maybe not the same process to build it. So there is some thing to think about this. Tuning required for proxies and reflection. Because if you have some libraries like Jakarta validation, you could have some issues because it uses reflection of or other code like Kubernetes, where you could have proxies, or any libraries like that use proxies and reflection. You could have some issues because all the classes in GraalVM is loaded at the beginning at build time. So there is no class loading. So all these limits are a bit tricky and require a lot of configuration for very complex application. In conclusion, ultra-fast startup, optimized for the cloud, great for micro batch. It was the use case I have in my project. So the only thing I need now it is to process it to put it in container and to test it in container. And it will be the subject of my next talk. So I thank you and for your attention, and don't hesitate to give me feedbacks because it is a preparation for future talk. So if you have any feedbacks, don't hesitate, put a comment in the video, and I will be glad to answer it and to check with you how I can make a better presentation in the future. Thank you very much. See you.